All right, we should be live. Here we go. Give me just a minute. Play some music in the background so it's not too dry. I think I've got all the audio issues fixed, so we should be good to go. And we're looking at this Bright Drop van, and I thought today we could look at the solar panels. We had a lot of good input, different ideas. You know, do you actuate them? Do they fold up? Do they slide out? Do they fold down along the side? What about shading issues? What are the best panels? That kind of thing. So I got a calculator up here, and we can try out a few different options, kind of see what might be the best way to go. So these are, let's bring up the panels first. Let's take a look. What I'm looking at right now is these Maxion cells, which is the same one. Oh gosh, I'm just drawing a blank here. The solar car. That'll come to me in a minute. But they're really efficient. They're flexible. They're durable, and they have these panels that they're looking at making potentially here in the U.S. soon, and they're about 2 meters long, so 2,000 millimeters by 80 millimeters, and the max can put out 340 watts per channel or per cell at almost 21. I don't know if you can see this. At almost 21% efficient. So that's what I've got modeled here. I've got 1, 2, 3, 4, 5, 6. So you've got 3 arrays. Each of them has 6. So what's 6 times 340? You've got that much per, and then times 3 for a total of just over 6,000 watts. So let's try out a few scenarios. For location, you know, it really depends on where you're at. So if we look here, you can see solar radiation. Where I'm at up here in Michigan, it's not so great. And then you get down in here towards California, Arizona, New Mexico, it's really good. But if we pick kind of a middle of the road, you know, right in Oklahoma City, kind of in the middle of everything, it might be kind of a good average. So Oklahoma City. All right, so in Oklahoma, and this calculator done by National Renewable Energies Lab, it accounts for weather variation, I think averaged over 10 years. And you can get the actual Excel data, and I'll put the links in here, and you can really analyze it and go more detail. But this quick little online calculator is pretty nice. So let's just call it 600 watts, 6 kilowatts, round number. These are premium. If we look at efficiency here, premium, 21% efficient. At 35 degrees, or 35.35% loss per degree Celsius. So the temperature degradation, 0.35. Let's see what these are coming in at. Right here, 0.29. So they're even better. These SunPower panels, well, they used to be SunPower, now they're Maxion, are pretty good. So that's good. Then we have our options here, fixed. Open rack is good because you can it gets the cooling from below. It goes over the information here. You have your tilt, you know, how much it's tilted facing the sun. Your azimuth, where it's directionally tilted towards. So 180 would be directly south. And then if you have tracking, where you have one axis, it tracks over the tilt angle, or 2 axis, it tracks everywhere. So we'll go fixed open rack first. System loss, kind of gives a default value. Soiling, you know, I want to assume these are clean. You can clean them pretty easy. Shading should be out in the open, although we are going to have that middle panel shaded potentially, depends on how we design it, if we get rid of that or not. Snow, mismatch, do we have mismatched panels? No, they'll all be the same. Wiring, our leads are going to be really short. I don't anticipate much there. Connections, you know, kind of aging the panel and things like that. So for these brand new panels right out of the gate, we'll get, we'll just assume it's 0. We'll go for the max, just see what we can get. And if they're tilt angle here, so how do we track? Let's see. Let's say we're looking at it, we are the sun looking down at the vehicle, and it's going to be parked like this. So the sun is going to rise here to the right, come up, and set on the left side. So it's probably the most efficient. And then these would track up and down. Oh, I still have that gear constraint on there. Hold on, let me get rid of that. I did that for a quick animation. I'll just suppress it there. So the sun would rise, it would be facing like this. You're going to get a ton of energy, and then as the sun sets, this one comes all the way to this side, and this one will go up vertical. Alternatively, you could have it static, and you could have them facing optimal for whatever latitude you're at. And then you would, if you're the sun, then you would look at it like this. So the sun would still come from the right to the left side, but if you had a static array, this would probably be the best setup. But this middle section here, it's basically, it's flat on the ground. So if we look at our tilt angle here, for this scenario, it's 0. And if it's fixed, that would be, let's just say there's slide out. It's like this. So fixed, it's flat, 0, 0. In which case, if this is 0, our azimuth doesn't matter because it's not pointing anywhere. And then we can check the calculations. And we have AC energy kilowatt hours per month for a total. This is pretty good. Let's take a look numerically and see. So when I went from New York City to LA, I think I used 7, maybe it was 800 kilowatt hours total. So, and I planned to leave in September, ended up leaving in October, and I didn't get there till the end of November. So let's say we average those two, which would be about 500-600. And I used 700 or maybe 800, I forget. So that would almost be, you know, I could have made it in a month, but I had a lot of shading. I don't remember if you've seen a lot of the videos. I think one here we've been following since the Tesla journey. So cool. Yeah, so I had a lot of shading issues, and I couldn't get anywhere near these numbers. My estimate originally for the Cannonball run was 20 days optimal, everything went perfect, sunny every day, 30 days likely, 40 days worst case scenario. And it ended up being just shy of 2 months. So, but in this scenario, we get rid of a lot of those shading issues because a lot of them were grass and ground obstacles were shading it, and the panels in the front were shading the panels behind. And that really kills the cells. A lot of people comment that if you just shade a few of these, you kill the output of the whole panel because it's all in series. So if you shade a few of these, they turn them into resistors and it just knocks out your whole array. So that was some of the problems I had. But you can see we've got, in the summer, we've got over 1,000 kilowatt hours a month. And if we look at the Bright Drop van, which I'm working on a little bit more advanced Excel spreadsheet on the van. I'll post this in Onshape too so everyone can pull it down. But the battery is 173 kilowatt hours. So let's take that number and we get 1,000 kilowatt hours in a month. So 1,000-ish divide by 173. That means in theory we could take the Bright Drop van, drain it completely empty, and charge it full almost 6 times in 1 month. And if you drive conservatively, you can get 3,000 or 300 miles per complete charge. So in theory, in a good summer month, you could go almost 2,000 miles on just solar, assuming you take advantage of every bit of sun you get that month. so you'd only drive at night, etc. It's pretty good. In fact, maybe this thing could do a cannonball run quicker than I did. And that is no tracking, just completely flat. So let's see. Actually, I'll take a note of these numbers here as we're going. I'll just put them here for now. So we've got a max of 1,164. If we go back to the system, and now instead of fixed, we are one axis tracking. That bumps us up to 1,000. So what's the highest? 468. 1,468. So that's as it's designed right now with actuators, assuming no shading. Which, another thought there, well, I'll cover that later, what happens if we drop these down, what kind of options. But the next option someone mentioned is, well, why don't you just leave them flat and use bifacials, because they're going to collect a lot of that light that's bouncing around. So let's go fixed again, and this time we'll switch them to bifacials. Where is that? Oh, here it is, bifacial. Let's see, what does that get us? That gets us 1,161. It's almost the same as before. That's odd. I wonder if it helps with our total. Our total is 11,000 for the year. So let's turn bifacials off. Yeah, 10,700. So we do gain a little bit using bifacial, but surprisingly, we're not getting that much by adding tracking. I think the big advantage is when you do maybe you track on 2 axes. Let's try that. We'll turn bifacials are off. 2-axis tracking. Yeah, now that's where you get your big bump. So now we're 1,560. So if we just kind of compare our efficiency bump, we're getting about 34% improvement by going full tracking. I've heard it's somewhere around 40%, but this does include weather, so it's not considering a perfect ideal sunny day. But if we look at just tracking one axis, we're not really getting that much, so maybe a slide out array would be better, but that's got its own issues too. So we'll go back to one axis tracking. 12,470, so we're still getting some pretty good numbers here. Now if we are on one axis tracking and we can tilt them, so let's say we tilt them at 40 degrees, which, you know, maybe you park on a 40-degree hill. Let's see what that does. It doesn't help too much in the summer, but overall. But we're kind of in that range of, you know, 1,000 kilowatt hours to 1,500 kilowatt hours. So back to panels. What kind of options do we have, and how can we actuate these? I would like them, if they are folding, I would like them to fold onto the roof and be able to fold down to the side. It's not letting me move it. Come on, there we go. It's getting a little slow on me. slow. Well, you get the idea. So they're closed, they're sticking out, they're kind of goofy. So if we drop them down, let's see, we'll go into our file here. Oh, someone's trying to call me. Can't answer now. So let's go into the, I forget how I got there. Ah, here it is. This is what I'm looking for. So this is kind of the design tree here. We have these. Sketch, here's the sketch it's based off of. So if we drop them down from 200 to, let's say, 25, like that. And then we go back to the van. There. Now it looks a lot more streamlined, but you can't fold them onto the top now because they'd interfere. And that could be okay, but the idea is that this thing is going to have some passengers in the rear, and if you're driving down the road on a nice long road trip, you'd like to be able to look out the windows and enjoy the view. So for that aspect, it would be really nice if they could fold up on top. Let me go back there, put that number in, edit the sketch. This was 200. Changes that and that. And then go back to the assembly. Then we can fold them back up. But since we're not getting a huge bump from having them actuate, and that's not an easy task. So these are huge panels. They're 6 feet by, I think, 10 feet. Let's just measure it here. So I'll measure from here to here. We'll do feet. Okay, so it's 16 feet long by 6 feet. So if you got a wind load, that is going to rip these things around pretty good. So your actuator is going to have to be quite strong. And I thought probably planning for like a max wind load of 40 miles an hour that would hit one of these panels, but then having a protection mode where if it detects a 20 mile an hour gust, it would automatically fold up. So it'd be designed to handle 40 miles an hour, but 20 miles an hour it would fold up, and possibly have a feedback loop to where it's monitoring the motor and the gearbox, and if it sees a certain torque on the motor, that's mapped to a wind speed, and then it would fold up automatically. So, but then you still got that wind, and you got to fold against it, and you've got the weight of the structure, which it would be lightweight, similar to like a aileron on an airplane. So it would be designed just like a wing. It would have sheet metal with sheet metal stamped struts going throughout for lightweight and strength. But still, that's a lot of force to actuate. You know, we're talking probably a couple thousand foot-pounds of torque that motor would have to actuate against, and you'd have to have a pretty big reduction. I was thinking maybe 1,000 to 1 reduction would probably be around what you'd need. Let's see what we got in the comments here. Do you want to avoid the side mount arrays shading the roof array in the late afternoon? Yeah. If they slide out, they can be stacked underneath, and they won't protrude above. They won't be sticking above, and they should get rid of a lot of the shading. Do a 4-ball linkage hinge. 4-ball linkage hinge. I'm trying to imagine that. I'm not quite sure what that is, but if you have a picture of it, drop it in Discord. In fact, let me get Discord. So if you go to Discord, go in the Onshape, there should be a link in the description here. Let me know if it works. But if you find a picture of it, just drop it in Discord, and I'll be able to see it. place them in a box and have them slide out with the top of the box, middle of the panel. This is too complex, but I love what you're doing. You're just too smart. Yeah, so I'm a gearbox engineer, and the common saying is to a hammer, every problem looks like a nail. So when I see a problem like, oh, I could solve this with a really nice gearbox, but that's not always the best solution. That gets complicated, expensive. Even if you design it yourself and you have good manufacturing, that's still a lot. So yeah, I can't be the hammer looking for a nail. Sliding straight and leveling flat would save weight and increase reliability big time. Less efficient for sure. Yep. So let's look at slides. When I was prototyping a lot of stuff, my slogan was faster, faster, buy it from McMaster. Because they've got everything and it's easy to find. You don't even have to know what you're looking for. You just look at pictures and be like, yeah, that's kind of what I need. So you got fasteners, tubing, linear motion, actuators, bearings, shafts. Well, it's probably shafts. Linear motion slides. You've got ball screws. What a lot of people I think are familiar with are drawer slides. And they make heavy duty ones, and I think this is what people that have slide out arrays typically use. The problem is they're not really good for automotive. They've got these telescoping feature where they got balls on both sides so that you can get something that's a certain length and it can slide out to match that same length. And it's got kind of this intermediary that goes halfway on each side. The problem is you've got all this is exposed to the atmosphere and the climate. So when you're driving down the road, you're behind that semi on a winter slushy day, and they've salted the roads and you get that mist all over your car. That is salt water just spraying everywhere, which will corrode these kind of things real quick. And maybe you could put like a large rubber boot, telescoping boot or something that would seal it up, but it's just really hard. Or when the thing closes up and it's completely closed, then maybe there's a gasket to seal all the way around, and that way you're sealed. But they're really hard to seal up, and they are heavy. If you're going to do something this big, they're still pretty heavy to handle that load. So we got those. What I like for sealing though is track rollers or cam followers. Let's see here, let's do cam follower. So motorhomes in the comments here have slide out storage trays rated to thousands of pounds. That's true. I haven't looked at those slide outs to see exactly what they're using. I should look that up. That's the first thing you do is you go figure out what's already out there instead of trying to invent your own thing every time. So for track followers, I like these V-groove because they'll stabilize in both ways, and they should have stainless steel, and they're sealed up so you can get all the bearings and everything grease packed and sealed. And then the exterior is stainless steel, so they're rust and corrosion resistant. Let's sort on V-groove, and then stainless steel 440C with seals, 440C without seals. 440C stainless is a really hard stainless steel that can be used for bearing applications, so marine applications will use it. It does rust though, all stainless steel rusts. It's just how resistant it is to rust, but it will rust eventually. But all the ball bearings inside, as long as those are sealed up, you're good. And if we get to kind of our radial load, looking at maybe 2,000 pounds, those are not cheap. But I'd say McMaster is usually marking up maybe 300%. I've purchased some things before, some springs and stuff like that. Once I went to the actual supplier, it was a third the price. but you never know. It's different for every part. So I buy it from a master car at first, and then once you start getting into volumes, then you go directly to the supplier. Just get an idea for the size here. So yeah, they're not small, but you could potentially have these nested inside 2 tracks, and then you could roll it out. Another option is maybe it slides out and then it pivots, and it has a stand, something that you can attach to. So you can slide it out and you can still pivot it for optimal position, kind of statically. Okay, we got the 4-bar linkage. Let me grab that. So here's what someone was referring to, a 4-bar. So it's going to go up and out, and depending on how you make these, you can make it tilt at the same time. So if you had a 4-bar on there, I'm trying to imagine it here, it could potentially lift off and pivot back at the same time. So as it folds up, it still gains the height to come back on top. And then we just need to figure out a way to actuate it. Maybe something like this, maybe a hydraulic piston or something, electric driven hydraulic piston. But yeah, that'd be fun to play around with. See if we can get some kind of 4-bar link or 2-link system like that. Similar to like a double wishbone suspension on a vehicle. They can get a lot of variation in how it behaves by changing these pivot points. In fact, I saw a while ago there was some project at a university where you could describe a motion, and then the algorithm would calculate what kind of linkage could make that exact motion. And it was crazy. Like you could say, make my signature, and it would come up with a linkage system that would make your signature. Now, not practical, but for something simple, you know, maybe you could sketch it out and say, hey, I wanted to kind of move up and over like this. Now solve for the linkage system that would do that. And if it's manufacturable, then that'd be pretty cool. Let's see what else we got in the comments here. Well, you know that the slide out on a RV slide out. Curious what they what kind of system. It looks like maybe the drawer slides. But this isn't like the slide out section. This is just, but yeah, drawer slides. But then the actual slide out living section, I wonder if they use the same thing or if they're using something else. Let's see, I got comments in 2 places here. I've never seen anything heavy enough that would be non-rusting or sealed, but they will work with lubing often. Okay, yeah. It's kind of like old cars, just grease zerks everywhere. You just keep pumping in grease and pumping all the junk out. How much solar am I targeting? 6,000 watts. In fact, let's go inside here. If you turn on perspective view in Onshape, it'll let you kind of fly in through a wall and you can see inside. So we got 6,000 on top, and then I was toying around with batteries. Let me just go ahead and section it, chop off this wall. So rack mount batteries, and then these are marine grade batteries. A rack mount, this would be a 25 kilowatt hour. This marine system down here would be a 30 kilowatt hours. So you should be able to charge it up in a full, a day, no problem, and then be able to charge the van. So this inverter here it's not that heavy. It's 120 pounds, but it's 15,000 watt inverter, and it'll do 48 volt DC battery system with almost 300 amps DC. It'll do 120 volt AC and 240 volt AC. So you could do a level 2 charging on the van, and the van charge port is right down here. They have two versions. One is 11 kilowatt, and I think one's a 17 kilowatt charge. So you could do the 11 kilowatt charge no problem with the inverter. And with the solar, you'd have enough excess solar that whatever you're powering in the van, you have plenty left over to charge the van. So you get out into the middle of nowhere, you can go stay for a week, and by the time you're ready to go, you could have the whole van topped off and charged, ready to go somewhere else. Let's see. So that's the solar panels. I think I'm going to investigate and spend some time trying to map out what a slide out would look like and calculate the loads, the wind load, and size an appropriate slide out, and then see if we could seal that up, or if we use cam followers that are already kind of sealed and they could ride on grooves. And for manufacturing the structural and the frame, I was thinking to use techniques by trailer builders. There's a lot of aluminum trailer builders here in the US that fabricate up and weld up trailers, and kind of the extruded, square section aluminum welded together can make a nice stiff frame. And then the bright drop van, you can tie in kind of on this lip here, is tied in pretty structural to these aluminum rails here and here, which are kind of cage off. They're pretty stout, but also in the front, which I haven't modeled here yet, is a really heavy bulkhead, aluminum bulkhead in the front and the rear. So if the solar panel mount had kind of a structure in the front and a structure in the back, you could tie directly into those bulkheads and you'd be incredibly rigid. So there's the mounting is pretty easy, I think. And the roof is just real thin. So idea is to not even touch the roof and have an air gap between the panels and the roof to get cooling and everything behind the panel. So yeah, so you got the Solarc 15K, which, oh, that's the battery. So this is the inverter. And then this is one of the batteries I was looking at. I just did a quick model on it. It's an SOK battery. I think these are about 1,000 a piece, and they are, I forget the capacity. I have it written down somewhere, but they're pretty good value. Most of the cells are coming out of China anyway. They're all lithium iron phosphate pouch or prismatic cells, so they're not cylindrical. The cylindrical are a little safer because they can handle pressure. The pouches will expand. If you've ever seen some of these when they go bad, they start getting gas in the pouch and it starts expanding and building up pressure, and that can be an issue. But lithium iron phosphate is pretty safe chemistry compared to the normal batteries in an EV, but it doesn't have the same power density. So if you're designing a car and you need absolute maximum range, then these aren't the best choice, but they're lower cost. So China is actually leaning heavily into lithium iron phosphate, and they do have way better durability, cycle count. So a lithium ion battery cylindrical cell will retain its full capacity for about 500 charge-discharge cycles. You might say, well, that's not very many, but a full charge-discharge cycle on an EV is, say, 300 miles times 500 cycles. So that's a 150,000 mile battery. And that's not when it's bad, that's just when the degradation starts to get to you. So maybe it's like 90 or 80%. But these lithium iron phosphate, like 5,000 charge discharge cycles. So 5,000 times 300 miles, that's a 1 million mile, 2 million mile battery right there. So that's pretty incredible. And they're lower cost. So that's why I think China is leaning heavily into these. And they have the biggest production and manufacturing. So you can buy them in the US, but chances are the cells are coming from China anyway. And the rack mount, they're a little easier sometime, but I'm not too sure about shock and vibration. I like something that's like these marine grade or something that's designed for a mobile application. Briggs & Strat does have a really nice battery, but they're kind of expensive. Really good durability, but their cost per kilowatt is pretty high. So I think the bogey, the target that most companies are going for, I know when I was at GM, I think it was $100 per kilowatt. Now that was their cost, raw manufacturing. That doesn't include battery management system, structures, all that stuff. But let's just say it was $100 per kilowatt, and you have a EV that's 85 kilowatts times 100, so you have a battery cost of $8,000. We know that right now, if you have to replace an EV battery, it's probably double that. So between 10 and 20,000. They're not quite there yet, but they're getting there. And some of these cells down here, because they're a complete package with the battery management and everything, and its retail price, I think they're around $300 a kilowatt hour. So if this was 30 kilowatt hours times $300, that's about $9,000 just in batteries. I think these are a little cheaper, but I think they were $250. So 30 times 250, so $7,000. Not cheap, but that's a lot of battery power. Oh, and options too, configurations. I mean, the simplest is you just get rid of the 2 extra panels and just have the roof, and that's 2,000 watts right there. Then you can downsize your batteries, you can downsize your inverter, you can make a much lighter, leaner system and save a lot of money. And it's just an optional thing, which I haven't done yet, but in Onshape you can do different configurations. So you can play around with it and make multiple configurations. And it keeps track of everything. Let's see here. Example. We go back a few versions here. I was improving the accuracy of the model. So if I look at the body, how I originally had modeled it, I'd taken these sketches, which were pictures, and then I drew on top of the picture and sketched the profile, and then I matched it with actual dimensions that I measured. And so I did the same thing for the back of the van. But when you do that, you can see it's not, you can see how I kind of had to estimate it because the picture isn't square, it's not a perfect picture. So there's kind of a lot of guesstimations going on. So I started working on it, I got some better pictures, and in the process, I broke the model. So it bricked every feature on the feature tree because I was editing up at the beginning of the feature tree, and so it breaks everything down past that. So what I did is I branched it off, and then I kept working on the main where that was still working, and then once I got all the errors fixed in the body of the bright drop van, I merged it back together, and it tells you pick what you want to keep and don't keep, and it merges everything back together. It's super slick. And now my sketch is based off of a sketch out of NX. That's the CAD program GM uses. And so a screenshot out of NX is going to be dimensionally, or not dimensionally, but proportionally pretty much perfect. So if you just know one dimension, you know all the dimensions. So I did that for both the front and the rear sketch. And now you can see everything lines up. There's no gaps. So this one now should be dimensionally more accurate. And then also I have access to a van that I can go take measurements of, and I have the GM CAD data. However, the CAD data is confidential, I can't share it, but if I need to take measurements or get details, I can. So I can keep refining it off of the GM CAD. I just can't put that in Onshape here because this is all open source, everyone can see it. So that's the good news. And this should be much more accurate now. So if you pull up the bright drop van itself, the interior dimensions, everything that's dimensioned here should be pretty accurate, and you can click on it and see how it was drawn. Some of it, if it's blue, it's not fully constrained, so I didn't have the exact dimensions for that. But now that I have the GM models, I can correct that and get them more accurate. Oh, let's see the comments here. You've got to do a rolling garage. The package can go over the top and you only need panels on the side top. Open the garage door and the panels power the other side. A rolling garage door. Not quite sure I understand that comment. But it does bring up the rolling garage door. I go back to the camper van. So it has a rolling garage door, which I've deleted here. And after looking at it and talking to some people, I think that garage door's got to go. One, it's really noisy, it clanks a lot, it's hard to insulate, and it takes up a lot of real estate inside the van. Go inside again. So this bed, I want it to be able to raise and lower. So you can have it, this is a queen size bed, so it lowers down, you can sleep on it. It raises up, but about as high as you can get it is up to this feature here before it starts to interfere. And the garage door takes up all this extra space in the back of the van. So you lose a bunch of headroom, just extra space that's just wasted. So I'm thinking of probably like a double door opening on the back, a traditional van door. And you can build out in the frame. And I don't have it modeled yet, but it's behind this plastic facade here is where the garage door does bolt in. There's already studs that are already built in. So you bolt out the garage door and there's already a frame and a studded frame that you can bolt right into. So once you get the dimensions, you should be able to build it out, install it, and then just bolt it right in. No need to add any extra fasteners or anything. So that's that. So I guess for updates, really I made the van itself more accurate dimensionally. I haven't played with the solar too much. I did add the Solar converter, which is actually pretty cool because that's what I used on the Cannonball run, a smaller one, a 5K. This is a 15K. And they thought it was pretty cool, so they reached out and they said they would send me one if and when I need it. So at first I thought, well, 15,000 watts is so much overkill. But if you're going to charge the van, you could really use it, because if you can only charge it, say 5 or 6,000 watts, it takes forever to charge the van. Now, granted, you might only getting that much from solar, but your solar can slowly trickle charge and get your battery charged up, and then you can dump that all in really quick. So if you're stuck somewhere and you need to get an extra 30, 40, 50 miles of range, having a more powerful inverter is really helpful. And it helps make this more versatile. So it's not just a camper van. You could build it out with just the inverter and solar and batteries, and then it can be a utility truck for anything. So you could power whatever you want. I mean, a 15 kilowatt, that's a house, right? You could power your whole home. And then the next thing is can you tie into the GM batteries? Which I did see a cool option in 2026. The onboard exportable power module is going to be available. So I think it's 7 kilowatt, single and split phase, or 120 volt and 240 volt. If that's the case, you could potentially get rid of all the batteries, and you just need some way to direct charge the van with solar. There was a company that was working on it. They kind of put it on hold. I'm not sure exactly why, but I suspect it's more difficult than it looks, because solar is really intermittent, and the charging protocol standards, when you plug in, there's big contactors that have to open and close that high voltage system for safety. And from what I've heard, that is not designed for on-off operation. So if solar, it gets cloudy and it's sunny and cloudy and sunny, it'd be like throwing that switch on, off, on, off, on, off. You wouldn't want to go to your breaker box in your house and just be throwing breakers on and off all the time. It's not really designed for that. So they've designed it for you start charging and you stay charging. Maybe you have an intermittent interrupt, but for the most part, it's you start and you stay charging. So for that reason, some of them have gone to a battery-based DC-DC charger. So you still have your 48 volt battery. You're charging that with solar, but then it takes that and boosts it up to the 400 volt charge current, or charge voltage, and then you have a consistent charge. So the battery's just acting as a big capacitor to prevent system shutdowns and on-off scenarios. So with that in place, if you get one of those, then all you would need potentially is a battery, a smaller one, and a DC-DC charge controller. And you could charge the van on solar and then use the van's exportable power to power everything else. That would be a simpler, maybe the most ideal scenario. Only downside would be is you'd then be limited to the 7 kilowatt. So if you wanted to really power something big, you would still need something like this 15K Solarc or similar. So that's kind of the update there. Check comments here. Looks like we got, how many people? We got 18 people on. It's pretty cool. Take a little drink break here. Oh, I forgot to ask, how was the audio? Last time I had a kind of an echoing going on. Audio's good. Okay, cool. Oh, that's the other thing. So I'm working on the next video, and I was thinking of going over the Powertrain. Volume's low. Okay. I think I can boost that. Let me see. All right, I want to boost up my voice by 3 decibels. Let's see, does that sound better, worse, or how's that sound? So I know some of my videos, the audio is lower than other YouTube videos, so if you switch back, it gets real loud, and you switch to mine, it's quiet. Well, I'm still learning all this stuff. Okay, good, all right. So here's what I'm working on for the powertrain analysis. Because this bright drop van actually has the motors out of the Hummer front and rear, but they've derated the power. See, biggest problem is not being able to feed solar to the large pack directly. Yes, that would need to be a design consideration from the manufacturer though, exactly. Yeah, there was a big battery show here in Detroit every year, and I did see companies that were making PV modules to charge batteries, and they were built into the onboard charger. But they were only for like 600 watts. They were designed for like the rooftop solar kind of application. So I put in a few different Hummers in here kind of as a comparison. So you have the 2X, which is the 2 motor, you have the 3 motor, 3X, and then you have the watts to freedom, WTF, 2 motor, and the 3 motor watts to freedom, which they just kind of take the brakes off the system and let you go full, you know, they really juice it. And then I have a little lookup here so you can switch which one you want. So if you want to go with the bright drop, and all these cells this color are inputs, and it's a lookup feature. It just says look over here at A1 and then go find it over here and then find the corresponding value and dump it in. So that way I can just quickly toggle back and forth between different variants, and then we can fill out the data here. Well, let's see, the rolling, so this is, I think, answering that one question. The rolling garage door would go from one side over the top to the other side. It has nothing to do with the rear slider. Okay, oh, so it would go over the top of the vehicle. Yeah, that would, so that's another issue is range in an EV is hugely determined by aerodynamics. It has very little to do with weight. So some people have commented, well, what's the range when it's fully loaded? It's, well, it's about the same. Especially in electric vehicles. You know, in a truck, a gas truck, it matters more because you use the gas to accelerate all the mass, and then when you brake, you just dump it all into heat into the brake rotors. But electric vehicle, when you brake, it regens and puts it back into the battery. So the city driving EVs are usually better than they are highway, and it's the inverse for ICE. They're better highway than city. So as long as we can keep the exterior structure as clean as possible and put fairings and keep it as aerodynamic as possible, we shouldn't see too much loss of range. So, powertrain analysis. So the Hummer, let's look at the 200 WTF. They've rated it at 600 horsepower. And what they do is they use the same drive motor in all the powertrain options. And they even have it listed down here. You can see, I pulled this right from their data. They have the X77R, they have the X81F, and the X80F. So the X is experimental, and the number is just a sequential number. When I was at GM, I was X69, that was our transmission program, which turned into CVT 250, which turned into VT 40. So these were developed after. You can see the 77 was first, and then the 80 and the 81. And then whether it's a front or a rear. And I think the major difference between the 80 and the 81 is the final drive ratios are different. And one might have park and the other doesn't have park. So only need to put a park system on one axle. To save money, they'll just pick whichever one's easiest and just do one. But these each have a 250 kilowatt motor, which is about 330 horsepower. Is that right? Yeah. So if you have 3 of them, you have 1,000 horsepower. If you have 2 of them, you have 630 horsepower. And if you have 1 of them, you have 330 horsepower. But then they derate it. So if you look at the Hummer 2X watts to freedom, you're at 600 horsepower. Then if you get a regular, they derate it to 570 horsepower. And if you get the Bright Drop, which has the same motors, it's derated to 300 horsepower. But they do have a little higher torque numbers. So I put the torque in for each motor. Let's see. Transmission, here's the ratios. You can have the front wheel drive, which has just got 1 drive ratio, or you can have the dual motor, which has 2 ratios, 1 for each motor. And then where's the torque? Okay, motor torque for the all-wheel drive. And what I've done is these are all the cells I use to calculate off of, and then I convert them to different units that are easier to understand. So everything here is SI units, so the equations are really simple. Everything here is, horsepower, foot-pounds, miles per hour, things that we understand. Like speed, wheel speed. For calculations, I use radians per second, but that doesn't mean anything to me. So I put RPM over here. So torque. The single motor, it's 405 newton meters of torque, almost 300 foot-pounds. And that's before the final drive ratio. And these motors typically have 2 ratings. They have a torque rating and a power rating. So we look down a motor curve here. This would be the torque. So it starts off at a torque until it reaches a power, and then the torque starts dropping off exponentially as power stays constant. And I can probably go over this in another video, but the idea here is to see how much torque we're actually putting to the ground and how capable the Bright Drop van is going to be kind of going off-road and handling a lot of weight, because it's got some pretty powerful motors in it. They are derated, but it's got really powerful motors. So I've heard it does better than the Sprinter vans, the 4-wheel drive Sprinter vans, when they're trying to go up a grade or something. It just has a lot more oomph to it. So that's another thing I'm working on. Let's see, comments here. Regarding the solar panels, what about putting panels underneath the vehicle since the Bright Drop is high off the ground? Underneath. Yeah, you could put some under there, but then you lose your ground clearance, which we're just talking about going off-road. Ground clearance is pretty important. I forget what it is, if it's like 10 inches. But you do have some room back here. So if you look under the front segment here is all battery. And then you have the drive motor here, and you have a spare tire back here, and then around the spare tire you have a bunch of extra space. But you do have extra trackers on, I think the Solark has 4 MPPT controllers, So you could put one on all 3 arrays and still have a 4th one for an external array if you wanted to set up another external array. Or let's say you have a remote property somewhere and you put up a solar awning or a carport that you could then just plug into as an auxiliary. So you could have a solar inputs somewhere where you could plug in a second array to kind of supplement your charging. But I'll say my experience setting up solar arrays, I'd rather not. I'd rather just get there, push a button, the whole thing opens up, whether it's a slide out, a pivot, some kind of cool 4-bar link. If it's a slide out array, you know, you could do electric, hydraulic, or maybe pneumatic. Air compressors are noisy and annoying, but they make quiet ones that are used for air suspension systems in vehicles. And it would be really cool to have onboard compressed air. So let's say you're mountain biking or something, and you just have compressed air for your stand-up paddleboard, your tires, whatever. You know, maybe you even want to deflate the tires. You're getting in some sandy conditions on the Bright Drop van, and this thing does weigh a ton. You might want to deflate your tires a little bit to get some more traction, and then have a quick compressor where you can come out and just reflate them real quick. So that could be cool. Well, I think that's kind of all I got for today. I'm gonna try and get the next video out here this week and then keep working on it. So again, if you have any ideas like the 4-bar link or anything, throw it in the chat in Discord, and then we have a record of it. We can go back to it and check it out. So I think that'll be it for today. I will end the stream, and thanks for watching.